presentation. So welcome to the Advanced OpenFlow tutorial. You've already seen a dry run of this in the plenary. So, and because this is, a more advanced tutorial, first of all, have you all seen how do you reserve resources in GENI? Have you done this while you were here? Great. So everyone has done this because we're going to completely skip this step so that we can focus more on the OpenFlow portion. And so in this tutorial, it will be a little bit different than the other ones. You're going to be working most of the times, and we're just going to be around to help you. So we're not going to do it step by step. I'm doing something, you are doing it. So we gave you the instructions. The instructions are also if you start the VM and you go to the Advanced OpenFlow, it will have a link to the instructions just in case you need to copy paste stuff from in terms of commands. Okay? So this tutorial started, we had a load balancer exercise, and we're like, wouldn't it be great to integrate it with GEMI, because in the last GEC they actually showed OpenFlow being monitored by GEMI. And that's how it started, and Shufeng joined us at the GENI project office to do his internship this summer. So he took up the task, and he was working with Divya, which was also at the GPO, and they tried to put this together, and you saw it in the morning exactly how it's going to work. So now it's your chance to do the same thing by yourselves. Okay, so GENI is a programmable network, and I'm sure you've seen this. If you've been in any of the intro talks we ever give, I'm pretty sure you've seen this slide. So the basic concepts in GENI is slice and programmability. And the problem is that the internet is open to innovation, but only at the application layer. You can only innovate at the end. You cannot really innovate at the core. And in GENI, what we try to do is to open the innovation in the middle of the network. And OpenFlow is a very great way to do that because it actually gives you access to the suites. It's just an API. It's an open API that if a suite supports it, then you can run a controller that is outside of the OpenFlow suites to control the OpenFlow switches. By the way, how many people here know about OpenFlow? Perfectly, because I'm not going to explain it. Very happy. So, and you can imagine that with the capabilities that OpenFlow gives you to run your controller from anywhere and control switches that are far away, this is a very powerful thing for GENI in order to be able to slice it and give you access in the core of the network to run your own algorithms. So how do we do OpenFlow in GENI? So by now, I'm sure you've heard that we have two types of racks, the inside GENI racks and the extra GENI racks, and both of them have an OpenFlow switch. So whenever you want to connect, you can always connect your compute resources, whether it's a VM or a real host, to a real OpenFlow switch, and then point that to your controller. And the racks provides, you can reserve your compute resources, you can reserve a slice of the OpenFlow switch and start running your controllers there. Both racks are compliant to the GENI API, so you can use the standard tools to reserve your resources there. And sorry. OK. And I'm sure you've seen this map again this morning. This presentation is so much easier when it's later in the GEC. So these are all the places we either have already installed racks or we are planning to install racks. And we see that we have more places and more interested actual places we have funding. So in next year, we're going to have a lot of racks, which actually this means for people that want to do OpenFlow research, a big OpenFlow network, right? It will be I don't know if it's the biggest OpenFlow network, but it's going to be really big in order to get interesting topologies and start testing out your controllers. Now, where else do we have OpenFlow switches in GENI? We install them in the core network. So both Internet 2 and National Lambda Rail have OpenFlow switches in their networks, and they connect to GENI. So when you're trying to go from one rack to another rack, you have the capability of passing through other OpenFlow switches that you can control exactly where to go. So you can imagine you can get interesting topologies, and you can get control all the way in the middle of your network. And also, we mentioned it also in the morning that there are also the regionals now start adding OpenFlow switches. So we're trying to get to a place where every switch, not every switch, but most switches on your path between your computer resource will actually be an OpenFlow switch that you can actually control. So we have an OpenFlow aggregate manager, which is called Foam. And that's how it's GENI API compliant. And this is exactly how you can reserve resources in OpenFlow. And they support an extension RSpec, which basically gives you the capability of saying, and this is the URL for my controller. right? So I want these resources from the switch, and this is the URL of my controller. Now, OpenFlow experiments. I've held, so in the beginning of GENI, we had like the mesoscale deployment, and people were actually starting from not knowing OpenFlow immediately to try and use the real deployment and OpenFlow switches, and this was very hard. It's extremely hard to debug. So imagine that you have access to these real OpenFlow switches and something does not work. You don't know it's the infrastructure, it's my controller. You cannot TCP dump on the interface. You don't have access to the actual switches. So it's very hard. You only can debug it end to end. So it gets really hard to debug your experiment if you are starting writing your controller on the real switches immediately. So there are multiple ways that you can start writing your controller. You can use Mininet, which is all in one VM, and bring up virtual switches, and you can have nodes to create traffic. Or another way that we're actually doing a lot in GENI is to use software switches, because then you can take a compute node in GENI, install OVS, and suddenly you have an OpenFlow switch that you have full control over. You can TCP dump on the interfaces, you can install any flows even manually, you can get statistics, you can see exactly what's happening. So it is much better to get a real GENI topology as you want it and just replace the hardware switch that you would normally have with a software switch just for debugging purposes. And then if you're ready, when you're ready and you feel more confident, you can migrate your experiment to actually use the hardware switches if that's useful for your experiment. Not all experiments need access to hardware switches, so you can even do your experiments only using software switches. So this is a slide that I wrote originally for the intro to OpenFlow tutorial. And I'm going to repeat it here because it's very important, and I see it all the time. What are the problems when you're trying to write your own OpenFlow controller? So when you write an OpenFlow controller, or when you want to use OpenFlow, suddenly you're responsible for all the traffic in the network. Traffic you didn't think or you didn't want to handle before, right? So let's say that you care about IP traffic on port 80. You have to also start worrying about the ARPs between your hosts. You have to worry about the DHCP. You have to even worry about traffic you didn't even know exists and might not even reach your host, like LLDP, which is a protocol that switches talk to each other to discover the topology. So suddenly, the moment you remove the logic of the switch and you replace it with OpenFlow, this becomes a very dumb box. And now you are responsible for handling all the traffic. And the most common thing that happens, the first thing that people forget to handle is ARP. So their hosts do not talk, and they're like, why? Right? So you have to keep in mind that the moment you want to do OpenFlow, you have to suddenly worry and make sure that you forward correctly all type of traffics. Another problem is, do you know what are reactive and proactive controllers? Have you heard a little bit? I'm going to explain it very quickly. So a reactive controller is that you expect to see the first packet of a flow before you actually make a decision and install the flows on the switches. Proactive controller is exactly the opposite. I know the traffic I expect. I'm going to install the flows on my switches. So when the first packet comes, it doesn't even have to come to my controller. Now, the problem with reactive controllers is UDP traffic. Because in reactive controllers, you don't have two ways. And for example, if you're using a learning switch, let's say you want to start testing and you want to use a learning switch, then you don't have the reverse traffic for your switches to learn the reverse path and the right ports. So what happens is that you have all these packets going to your controller continuously and you never learn the actual path. Or another problem, let's say you're not doing learning switch and you have a much smarter controller. If you start a UDP flow, it will start blasting packets into the network. It doesn't flow control itself like TCP, that it waits for the first few packets to be exchanged. So by the time the first packet goes to your controller, you make a decision and you install the flows, you have thousands of packets coming to your controller as well to be routed, because there is no rule yet in the OpenFlow switch. So you have to be very careful when you're designing your controller and you're using UDP traffic about exactly how you're going to handle this case. Are you going to just send a probe packet before to make sure that all the flows are installed and then start actually sending high volume traffic? Another problem we're having is performance in hardware switches. And the problem with that, like hardware switches are great and suddenly they give you this capability of actually controlling their flow table. The problem is that not all OpenFlow actions are supported in hardware. So in order to be able to support the full OpenFlow spec, what they do is they support as much as they can in hardware, and then they support the rest in software. And the problem with that is that the actual CPU on the switches is a very, very weak CPU. It doesn't match the CPU on your computers or any of that. So the moment you start doing actions that are actually implemented in the software, the performance goes down because suddenly all your packets have to go through the CPU of the switch. They're not hardware switched anymore. And you overwhelm the switch. So you can actually bring the switch down by spiking its CPU to 100%. So when you start using real hardware switches, you have to start worrying, does this switch support what I want to do in hardware? And if it doesn't, how am I going to take this into account performance-wise? Right? You cannot just start saying, I'm going to send a gigabit of traffic to a switch that supports some things in software. And another problem we've seen a lot, you don't have STP, you don't have spanning tree anymore. So if you have a loop topology and you don't make sure that your packets take only one path and you just broadcast everywhere, then you're suddenly going to bring down the network because of broadcast storms. So the important thing to notice is when you use OpenFlow, suddenly you're the network engineer in non-layers. You have to take care of everything. You have to care about loops. You have to worry about LLDP. So that's very important when you start designing your controllers. OK? And that's all I'm going to talk about OpenFlow in terms of introduction. Now we're just going to move to the fun part, which is the actual experiment we're going to do today. So I'm sure you've seen this before. We have the part 1. We're going to design and set up. Part 2 is execute. And part 3, by now, we're just going to delete our resources. OK? So for the part 1, we want to design a network load balancing controller. And in general, what is balanced service? We're trying to balance the load among multiple different servers. And you have this in web servers, in any place where you're trying to balance the load in order to improve performance. Now, in networking, what we do, we're trying to balance, to improve the performance of the network by balancing the traffic and the load between different paths. Right? So you have a multipath topology, and you're actually trying to balance this over 2 or more paths. And so in order to be able to run a load balancer, we need to have access to many decision points within the network. You cannot do that anymore at the ends. There are cases where you can do that. You can try to have multiple paths and only monitor the behavior at the end. But that is, it won't perform as good as when you actually have decision points within your network. So how does OpenFlow help us with that? So you have, I'm sure you've seen this before. This is the switch, and your controller runs somewhere outside. And suddenly the service that is performing the load balancer can communicate directly with all the switches in your path and actually get statistics from the switches. So you can see how much is the traffic per port, if you care, per flow, or in a table, in a forwarding table in case your switch supports multiple tables. So you can start doing the load balancing, taking into account the statistics here, and this is what we're going to try to do today. We're going to take into account statistics from the switch in order to decide which is the best path for our flow. Okay? So in today's experiment, we're just going to have 2 paths from source to destination, and we'll try to balance both paths to make sure that both paths are equally utilized, and to make sure that all the TCP flows we have will have similar performance. So design your experiment. You've seen these slides before. So these are all Shufeng slides. I'm just presenting them now. So you have your source, you have your destination, and you have your 2 paths. And we're going to we're going to start an OpenFlow controller in this switch only. This is an OpenFlow switch. It's going to be an OVS switch. And we're going to start the OpenFlow controller there that does the load balancing. And we're going to connect the OpenFlow switch to a controller. And just for convenience for this tutorial, the controller will run on the same box as your switch, so that you don't have to have tons of terminals open, and we don't waste a lot of resources. But you can imagine in a real environment, this can run anywhere. It can run on your machine back in your university. And we're going to start several TCP flows, and we'll try to balance them between the 2 flows that we have. And we're going to use GENI in order to orchestrate and design. And you're going to, first of all, start your controller. Then, then we're going to set our switch to connect to the controller that we have. And you don't need to understand, because I think most of these are already written, right? Yes. So, and then we're going to start the multiple TCP flows to make sure that that we load balance in between the 2 paths. And in order to monitor our experiment, to make sure that our controller works the way we expected it to work, we are going to use GENI, and we're just going to monitor the traffic that goes out this path and the traffic that goes out that path, and make sure that we're doing a good job while our controller is running. And these are the two graphs. You've seen them in the morning. We're going to just see the total, the aggregate traffic going out of each interface and the throughput of each interface to make sure that we actually do the correct load balancing. Now that we designed your experiment, the next step would be to obtain our resources. But we've already done this for you, so you don't have to wait until your resources come up. So this is, you can imagine it this way. But you have the outside is the source, the sender, and the inside node is the receiver. The switch is the actual OpenFlow switch where we're going to run our load balancer. And the aggregator is just another OpenFlow switch that imitates the decision made. So if a flow goes this path, the aggregator will make sure that the reverse traffic will also take the same path. And these are just switches. They're just going to do normal layer 2 switching. They're not going to make any decisions. Okay? So I want to stop here before we move to the next to make sure that you all have access to your resources. So are they all added to slices? At all? Okay, we'll fix that.
And one doesn't have his name. It's not in GEC17 project.
Okay, so I'll help you. It's already settled. We just need to add you to the slice then. Okay. And how many people from the people that are in the room and want to do the hands-on do not have instructions? 1, 2, only 2. Okay, we'll fix that in a bit. So what I want you to do is log into the portal and go to home, those of you that are already added in the slice. And if you go to the home, you should find a slice name that is equivalent to the slice that is written on the top of your instruction page. And that should be on the form of advanced, OpenFlow, and then that should be a number here, 01, 02, 04, 05. Okay? I want you to find that slice and click on it so that you load it. And if you scroll a little bit down, where it has all the aggregate managers, on the top it says status and get all. I want you to press the get all button and wait until it loads. One of all the aggregates should turn green. That means that is the aggregate that you actually have resources at. So do that, and I'm going to be around to help. And we'll also slices. Okay. There are only 2 people. Okay. You have to wear this while you do the slides there. Because there is warning. Okay, I'm gonna help to create this one.
You don't have to do it from the we are running out of slides.
No, I understand that. I'm going to work with you. So you don't need to do another go around. Explain, the steps they have to do, and then we'll go around to help them. Yes.
Already seen your resources and topologies? Raise your hands. So for those who are ready, log on to portal. I think I need to do a demo. And identify the aggregate manager that has your resources on, and click details button on that aggregate manager. It should display a list of nodes that you, with their public IP addresses and their login information, so that you know which IP address to do SSH to. You guys switch. So if you know the IP address of your of the node named switch, please log on to switch.
Who didn't have a portal account so they can help them?
Yeah, I have. No, you don't need password.
Yes, everything's. Should I use password too?
Who does not have a portal account?
Yep.
Switch, right?
Yep.
Outside.
And you use this. It's all right. Just use command line SSH. Oh, the password. Niky, have you told them the passphrase?
No, we're not there yet. So
Okay.
don't try to log into your resources yet. Bring up, after you find the green one, bring up black so that you can see your topology. And after we do that, I'll let you know how to log in. There's no login of me. Oh. You tried that?
Yeah, I've tried that.
Okay.
It works. But they need to do SSH add. They need to do SSH add, the share the key.
Yes, I'll do it.
Yeah.
So I'll do it.
What? Yep. Oh. Okay. What's the problem? Yours? Huh. I think it's this one. Yeah. Okay. It's weird. It's 54 and it's 24 here.
So who has figured out the resources and their green and everything's fine?
What's your last name? It's on the paper. 11. Okay. Let me see. And what is your name?
RAGA. Yeah.
Okay. I'm going to add you as a member. Okay. And if you refresh this page, and you should be able to see that slice. Yep. And you launch Black, then you can see the topology as well as the login information. Yeah, no problem. Yeah, we're not there yet. So just.
You're not gonna break
It would be much better if we had like 600 VMs.
Okay, I created the slice. Your keys are
You
not
don't have
there.
a slice yet.
Yes, sorry.
And
Okay,
have you
so
created an
we
account
have
yet?
created the slices before you were a
And-
member of the slice. So your keys are not loaded in the slice. So what we've done, we've used the third key that you can find inside the VM under the .ssh directory of your home directory. So you're gonna do ssh add the key. The password is GEC17 lowercase one word, and you're gonna use this key to log into your resources. For those of you that are moving ahead. Yes, we are doing that. So one person doesn't have a slide.
The only key is under .ssh. GENI share the key. Share the key, yeah. Oh, you're not in the correct directory.
No, that's fine. Okay, so I'm gonna show you how to log in.
Awesome, okay.
Okay, so that we can
GEC
all be at the same page for.
17. Yeah. Add it. Good. Oh,
Okay,
the
so for
script
those of
is
you
not on
that
the
are a
switch.
member of the slides already, and we're not creating a new slice for you, so you go to your slice. You go to your slice and you click here that says get on. And you wait for a while as it goes out and asks the aggregate to see if you have any resources there. And one of the resources will turn green. One of the EMs will turn yes. So, and one of the EM will turn green, hopefully. Except if Victor did something. Okay, so once you find out which of the EM turns green, in this case of the slice that I'm here, sorry. This is the University of Houston, the Exogen Iraq. Then you can press here that says details. And we'll wait for a while, and this will go and will bring up the manifest we were talking yesterday that will have all the information about how you can log into your resources. So, and here you will see all the switches that I were talking about. So we have the outside node that is the receiver, the right switch, the inside, which is the source, the sender. I don't remember. The aggregator, that's an OpenFlow switch, and this is the switch that the instruction tells you to log in at. Okay? And this is the SSH command. Before you click on the, so you can go to your terminal, and you should add the third key that we have already pre-installed. So you will have to run SSH add Okay? And the passphrase is GEC17, one word or lowercase. And after you do that, you can just copy this. Okay? And you can do this for all the resources. So whenever you need to log in, sorry, I'll make this. Okay, so whenever the instruction says log into this node, you can just copy and paste the command in the terminal. If you click on the link, then Fire SSH will come up, and what you have to do there is use GEC17 where it says password, and then you have to load the key that is the GENI cert key. You can use either of the two, either Fire SSH or your terminal, whatever you're more comfortable with. Okay? I'm not going to use this slide because I know it's someone's. Just wanted to show how to log into the resources. Has a slice and they're not here. They haven't been able to log in yet.
Yes.
I don't see them. Like it here.
Yeah, because we haven't added you into you don't have a slice. So in other words, you don't have a slice. We are running out of slices.
That's what I was just checking, and I don't see them yet. The only other thing is this.
Are you guys all able to log on to Switch?
What do I do next?
Just do what you see there.
Yeah, there is no GENI share.
Are you on the virtual machine?
Yes.
Okay. It's here. Oh, it's not here.
ID I received.
Which virtual machine are you using?
Divya.
Is GEC16 or 17? Well, did you see that key? Oh. Did you go? Can you go back to VirtualBox? Yeah, go back outside of the virtual machine so that. You're using GEC17 tutorial, right? Tutorial final. Let me check. Niky. Niky. He doesn't have the shared key on the .ssh.
On the VM?
Mm-hmm.
Can you do an LS36?
And then there's the OpenFlow tutorial.
GENI cert key.
But
We're good.
I was seeing the wrong document.
maybe you're in a wrong directory.
Oh, this is Shufeng.
Just click GEC17.
Have a slice called OpenFlow tutorial.
Yes,
Can we delete it?
that's fine. Yeah, sure.
Yes, you can delete that Shufeng.
And
You can delete it. It's
okay, hold on. No. Hold on. Right now you are added into the project, but you don't have any slice yet. So what I'm going to do is I'm going to add you into the slice as a member.
Okay.
So this is the name of the slice.
check with Divya. She's not doing, right?
No.
Okay, okay, then good.
This is the name of your slides.
Okay.
Could you tell me your name?
Gandhimati. GANDHI.
And I'm going to change you as a member.
Okay.
Okay, then refresh this page. Okay. Scroll up. Scroll down a little bit. You can see you click this and get all status. A GEC17 user. Scroll down a little bit because there are more aggregate managers there.
Okay.
So this means you have received your resources from FIU Excel GENI. Click details. This will give you the details of the nodes you have received, as well as their login information.
Okay.
So, and in our case, we are interested in the node switch. So scroll down, client ID left, scroll down, client ID outside, client ID switch. You need to log on to that node.
Okay. Okay, and then after that? After that?
You need to log into the node switch.
I have to click here, right?
Yes. just do what we have showed.
Okay, okay, thank you.
Yeah.
Okay, that's what I want to see. Thank you. So at this point, who does not have a slice or is not working with someone that has a slice? 1, 2.
Oh, the 没有4000。
Together until we create your slides. Because it might, I understand, I know, I sort of have believed that we will only have 16 people here. Ready with slices. No. Because I would have had you do it in the morning.
There is a mistake we made in our tutorial. The port number for LabWiki is actually 4000 instead of 3005. We use 4000. Yeah.
Ready to log in through. I am unable to find it.
Oh, it's confusing. You are using this command on your host, your local host, instead of on the switch.
Oh.
So since you have already find out the IP address for your switch, you don't need to do this.
Okay.
Just ignore 2.2.112. And if you have already found out a way to log on to switch, then please ignore step 2112.
Okay. Uh, Hi. I just want to say a couple of things about logging into LabWiki, because in the instruction sheet there's a URL which is not quite correct. We're not using that LabWiki now. So if whoever is logged into the portal, if you could all go to labwiki dot so labwiki.casa.umass.edu, and we have assigned port numbers to different sets of people, because the server is kind of getting overwhelmed and we had a little bit of problem yesterday. So I'll give you port numbers for a group of people, and please use that port number. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we totally have 10 ports, and could we have one port per table? I think that sounds okay. So if the 4 of you could use one port, that would be good, because there are some tables with 3 people, so you can start with 4000. And we have 4001 for the 2 gentlemen at in the third row, and then we have 4002, 4003, 4004, and 4005, 4006, 4007, 4008, and the last row gets 4009. So just labwiki.casa.umass.edu and your port number. And the GENI portal now uses the OpenID, which is you can just log in with your GENI portal ID, and if you are logged into the GENI portal, it will log you in automatically. And people who attended the previous GEC and GIMI tutorial would probably know that this is a new feature, because we had the portal login as different earlier, and there were a lot more procedures to be followed, which is the link that some people try to open up here. We don't have to do that anymore. You can just use your portal to log in. Okay, so is everyone here now? Okay. So I think everybody attended the plenary in the morning, right? Is there anybody who did not come to the plenary? Okay, so I won't explain too much about this. You can just do the steps there, and as Shufeng showed earlier, you can see the graphs there. You can click and drag, and that's basically to plan and maintain your experiment.
And the instructors on the sheet tell which they have to load, right?
Yeah.
Okay.
So here in the prepare column, you go and select the script. So Shufeng has created a really nice script for everyone here to use. So you can just go and select that script and change that and do whatever you want. Try your own load balancer. And all you have to do is remember to click on save, because if you don't click on save, the changes don't get reflected in your script, and you won't be able to see the changes in the graph. So you click on save when you change your script, and click and drag it over to the execute column. And another thing is, the experiment name should not have spaces or special characters. It's just one string, and if you enter spaces, you would probably again not be able to see your results. And the slice name should be the exact same name as the slice on your portal. So here it would be the ADVOFXX, where XX is replaced by your the name on your instruction sheet. And then you just scroll down and select true, and you can see your experiment. And Shufeng will walk you through the experiment a little later.
One thing that is important, and I'll go over there before I get yelled at. So one thing that is important is that if you're running an experiment and you decide you did something wrong, wait for it to finish before you drag another experiment, because then I don't know what will happen, something with GIMI. Okay, so wait until the experiment finishes and then make your change and run another experiment. It's very fast and very easy, so you should have no problem.
So for now, we are not using the plan column. So you can just ignore this column by clicking this icon here. That will actually expand the prepare column. You can actually focus more on the code.
Oh, by the way, I don't know for you, those of you that took, okay, I'll do that. So for those of you that attended tutorials, you probably already know that we'll be having an SSH problem with the hotel network. They told us it's fixed, and that's why we have you all using port 22. If you run into a problem that you get connection refused, let us know, and we have alternate ways for you to log into your hosts. But we're also stress testing it for a tutorial tomorrow that doesn't have another way of logging in, so we want to make sure that port 22 works. Victor, you said FIU?
So has everybody all logged on to Node Switch? Yes? Raise your hands if you have logged on to Node Switch. All right. All right. Then on Switch, do an if config to make sure that all the Ethernet interfaces are up, and you can see the IP addresses assigned to each of the interfaces. And in particular, you would be interested in the interfaces that has the IP address of 192.168.2.1 and .3.1. Memorize those two, the name of the interfaces, because you are going to need those in your LabWiki script.
Don't copy down these ones, let's find out which what corresponds to your script.
Yeah, your interface does not necessarily needs to be the same as mine. So basically, the interface that corresponds to the left pass is the interface with IP address 2.1. And the interface with IP address 3.1 corresponds to the interface that connects to right pass. After you identify those two interfaces, you need to change your LabWiki code. So you need to go back to LabWiki and scroll down this script to line. There is a line number in the tutorial page. To line 134. Yep. Here you modify these two lines so that it points to the correct interface. No, into the Ethernet number that you have. So probably it's ETH3 for you. It depends on the node. Yes. So, for example, when I log into Node Switch, I do I have config. I find that the interface name corresponds to this IP address 2.1 is ETH3. Then I update this to ETH3. The same for the right interface. So in this case, ETH1 corresponds to the IP address 3.1, that's the write interface. Need to change that into ETH1. And remember, when you change your script, this save icon will be activated. So you need to save before you do any further experiments. This step is simply to define which interfaces you want to monitor, because we are going to plot two graphs.
You have two that you should have been able to fire off one, and that there should be a second. Just as far as you would.
Okay, I just want to say a quick thing about LabWiki. You might see a message that says you don't have any projects or experiments, because we're still doing some development on that, and you will see some features in the future. So you can ignore that. It's not an error message. Your project is whatever you have in the GENI portal. Thanks.
You're way ahead. Yep, it's okay. All those information that's green means it's okay, it's doing right. Yeah. Are you following the instructions? Yeah. Did you forget this? You run a couple more commands that messes all those up. Yeah. See, the switch is ready. Switch ID, you don't see this line, which means the switch is not connected to the controller. So you need to turn it off. Start a new. Do you know the? Okay, let me log on to the. going to remove the switch from the controller and restart the switch controller and connect the switch back to the controller. Yep. And here, see, switch is ready. Yep.
So one step that might not be in the instructions, in case you don't remember from the morning, is that when it says run an experiment, the only thing you have to do is drag the icon over there. Don't do it, Shufeng, because we're going to mess up someone's experiment. But you can drag it all the way to where it says execute and just drop it there. And that will automatically execute the experiment. Oh, yes, it doesn't start, you're right. And then you can fill out all the information and press start experiment. Okay? So that is the way you load your script to GEMI in order to run it.
So before everybody else run any experiments on LabWiki, please make sure that you run the OpenFlow switch controller on the switch by following the instruction. No, it's not the same as the demo today. For this one, we have enabled controller from the start. This will remove the switch from the controller. It's just like starting a new experiment.
So after we remove it, we start this.
Yeah.
Run that whole line in one flow.
Because when you terminate your OpenFlow controller, you want to clear any OpenFlow entries in your OpenFlow switch. In order to do that, you have to disconnect the switch from the controller.
We have to do the process experiment, disconnect it and continue the other one.
Yep. Yes. Yeah. It's okay. It's a random message. Yeah.
Anyone needs help?
Wait. See? Switch is ready. And then you can do the experiment.
Divya, he doesn't see any ground. On O.
Yeah, you need to write. You need to specify you want to display graphs. True, type true. It's here. They removed it. Okay. Okay, hold on a second. So in order to display the graphs, I think it's missing in the tutorial page. You need to type true here at this box before you start the execution. It's normal. It's not a problem. Yeah. Could you check the log? Yeah. Yeah. Mm-hmm. Yeah. Which port number are you using? On LabWiki, which port number are you using? 4000. Wow. It's something wrong with LabWiki.
Yeah, one or two pages. Says 212. And there is no pins in section 31. That is something that confuses me.
Yeah. Yeah. It's in the bookmark of your node virtual machine. It seems that we are missing one whole page in the printed. So everybody goes on to your virtual machine and use the web page, which is, I think it's in the bookmark. Advanced OpenFlow. Load the web page. That's confusing. And just follow the instructions there, which is easier, I think. It's in the bookmark. So did anybody successfully see a graph? Wow.
Almost that far.
Nice. Nice. If you are ahead of everybody else, just go ahead and do the experiment. If you have any question, just ask us. It's a
Go to the default tab.
it's a hidden bug in that wiki. The first time you write, it only displays one graph.
Okay.
That's so the next time you write, it will display two.
Which one you said? Victor? Victor, which ones you said GTOM?
FIU and GTO.
Thanks.
More than half of them has already seen the graph. So that's step one.
That's good. That's good.
But I think port 4000 has some problem. So he's not able to see the graph.
Am I supposed to take a miss the word and disable?
Yes. Are you able to see the graph? Okay. Are you running the controller? You should be able to, and you're using port number 4000, right? That wiki. Check that wiki. Yeah, I think port number 4000 has some problem. This log means it's running correctly, and you can actually see how many flows are going to the left and how many flows are going to the right. Right? Left flow 12, right flow 12. So 12 is going to the left and 12 is going to the right. So try 471 in that wiki. Different port number. I think port 4000 is done.
When we're done.
Yeah.
You can yes, because people are already in the stage of writing, right?
I have a doubt. So when we started running the experiment,
Oh, don't follow this. It's
it's
2, 2, 3,
confusing.
read of 3.
What we were trying to follow the three
We're missing one whole page. So go to the web browser here
okay.
and use the bookmark across the web. Yeah, all the instructions are here.
Okay, fine. We have one more slice in case you want to do it also yourself, or you can do it later, or you can do it in the next session. What you want? Just I think it's fine. Up to you.
Again, do not follow the instructions that we have printed for you because we miss one whole page. Just follow the instructions online. It's in your bookmark here. Advanced OF.
Rerun the same thing for the second round. So I cannot make multiple runs.
You can also on, the inside. Oh, this is another. These are not an error. Which node is sticking out?
I will give me your name and I'll add you now. Okay.
Still
Am I
does.
using it or
Oh no, then it's working. So you need to log into. You see, scroll down to the bottom. Yeah, it's waiting for nodes outside inside switch because LabWiki is not able to recognize them. In this case, you need to log on to outside, inside, and switch and start the OML service. You need to start a new window right here and do ODS. First disconnect the switch, and then connect. You have already disconnected. Okay, then do that one.
Yeah.
Here start the balancer again before.
If you didn't see this line, which means that the switch is not connected. So could you open another terminal and log on to node switch? Yeah, I think it's in the instruction. Oh, it's a mess. Yep, and do OBS minus VS, control CTL, show. SHOW. Yep. And it says it's connected. So you want to remove the. You want to follow.
But I didn't get any.
so that you can always
Yeah, because the OpenFlow controller is not connected to the switch.
But here is connected.
Yeah, it's confusing. So you need to reconnect the switch. Just delete controller, then
you should be able to see your
add controller. This instruction is useless. So
Just I need to verify.
go back to the
Okay.
tutorial web page.
The inside node.
Okay, so that's the aggregator.
Just to disconnect and scroll down. Use this to reconnect.
Now we can start again. Balance script.
This instruction misses one page, so just follow whatever is on the right page. Yeah, you need to have two terminals. Those connected to the switch, and one do the gamma, the other do the connecting disconnect.
Oh, yeah. Okay.
Because otherwise it's. So how many of you is at the stage of ready to change the trauma code to run a new OpenFlow controller? Wow, nice. So I'm going to tell you a little bit about trauma. How many of you have written the OpenFlow controller before? That's nice. And how many of you have used the trauma before? Okay, good.
So while Shufeng is trying to bring up his slides, how many of you are running experiments and cannot see graphs? 2, 3, 4, 5, 6.
I think most of them are using port number 4000. If you are using port number 4000, try to use another port number.
Okay, use those of you that are having problems, switch to using in the lab wiki 4008.
4008. So basically, trauma is not an OpenFlow controller. Trauma is a tool or a platform that you can run your own OpenFlow controller. So one of the advantages of trauma is that it gives the user a set of OpenFlow APIs so that you can use directly to define your own OpenFlow controller. And it also provides the application trauma, which you can use to run your own controller. So trauma provides APIs for both C users and Ruby users. In this tutorial, we're using Ruby because it's simpler. And here are a list of the common functions provided by trauma. Start will be executed when your controller is up. And switch ready will be executed when the OpenFlow switch connects to your OpenFlow controller. So if you open the OpenFlow controller example we have on the node switch, the root directory of node switch, you can see that how we define these two functions. And there are many other functions that is provided by trauma. You just read through our examples to get a basic idea of what each of them does. Again, if you Google trauma, you will see a full document talking about the trauma APIs. Here is a very simple example about a OpenFlow controller. In start function, when the OpenFlow controller is started, I simply print hello trauma. if any OpenFlow switch is connected with my controller, I print something else. And if by default any packets that entered OpenFlow switch will be forwarded to the controller by the switch. In that case, when a packet comes into the OpenFlow controller, it will activate this packet in function. In this case, we simply add a flow entry saying that for this specific packet, I'm going to flood this packet out in every port. And how to run your OpenFlow controller? By simply running trauma run hello trauma.rb, as you guys already from the LabWiki script. So compared with other OpenFlow controller platforms like POX or Floodlight, I think the biggest advantage of Trauma is it's simple and easy to write. As you may already find out, the load balancer example we have provided only uses about 200 lines of code. So it's really simple. So in the next half part of our tutorial, you are going to write your own OpenFlow controller. And there were many comments in the example that we provided. Read through those comments and figure out how to modify the code. And if you have no idea how to do that, there is the solution as well. Just following the instructions online. On the tutorial web page at the bottom, there is a section hint. Go to section So on the tutorial page, scroll down, click part 2, execute. There is a section called appendix, and appendix A gives you all sorts of hints and explanations about the different functions in the load balancer we have provided. So this is where you should look into in order to modify your load balancer. And again, a quick jump start is to just find the solution that we have. I think it's in the instruction page. It's under /temp load balancer folder. on node switch, at your home directory, this load balancer.rb is the original example load balancer we have provided. Under temp load balancer folder, there is another file named load balancer solution. This is the actual solution. So if you don't know where to start, just compare these two files and see the difference. A lot of you have the question of how do I restart an OpenFlow controller in Trauma. It's a little bit tricky in Trauma because it's not just Control C to kill your Trauma process, then rerun it. After you kill your Trauma process, you actually need to disconnect your OpenFlow switch from the controller, that's Trauma. From the controller, then reconnect your OpenFlow switch back to your controller. I guess we have that script on the tutorial page.
So because in 5 minutes the session is officially over, I just want us to go through the whole presentation so that you can see the rest of for GENI and how do you archive your experiment. The next session, and I don't know if it's in this room, I'll find this out, there is the experimenter drop-in session that is very informal. People come and just try to run your experiment. So if you want to stay and keep working on your experiment, that's perfectly fine. We have until 5. I'll verify if this is the room, okay?
Okay, so I am just going to talk about LabWiki's measurement scripts and how you can write them, because I don't want to go into the details of other details of LabWiki because I'm sure you've heard it many times earlier. So it's developed by Niky and used for GENI, and as you all know, there's just 3 very simple steps. You just plan, prepare, and execute your experiment. And you can also see a video demonstration of LabWiki and its features at this URL. So this is what LabWiki looks like. And when you can plan your experiments, you write something called markdown scripts. So in the plenary demo earlier, what we showed is that you can drag and drop the graph from your execute window to your plan window. And it's very, very simple to write. So it's just 2 lines that you add there with the figure number and any description of the figure that you want. And you can also have other descriptions. And it's not like it's a big script that you need to know. That's the simplest here. Probably something that's comparatively more complicated would be the OMF script that you write, but in LabWiki we use OMLified applications. So all you have to do is call the applications that are there, and if the application has not been OMLified yet, you can write your own applications, like Kiran has done, and of course Shufeng has changed the OML trace application that exists. And whatever you put in LabWiki can be saved. This is what the markdown script that I was talking about. And the OMF scripts that you write are like Ruby, and it's quite simple to write. You just need to call the applications that are there and use the capabilities. These OMLified applications have measurement points defined so that it will do those measurements and store it in a database. And then from there, from the database, it's going to read the values and show you your graph. So like I mentioned earlier, it's very, very simple to change an existing script. You just make your changes, save it, drag it over, put in your slice name, put in an experiment name, and just run your experiment.
What is it used for backend database?
Right now we're using Postgres. Did you have a question? Did you have a question? Okay. So then you just run your experiment like we already did, and you drag and drop your graph. And just another thing that I wanted to mention is you don't have to wait for your experiment for the graphs to show up or even to drag and drop it. If the icon of the graph shows up, you can just drag that icon over to the left pane, to the plan pane, and you can see it live there as well. Okay, this diagram is what Shufeng has very nicely done, and I think it perfectly describes how LabWiki works. So what LabWiki does is we have something called a post-boot script, which is already specified in your R specs, which we use to reserve the resources. And in the post-boot scripts, you have a line that actually goes into the RCs and modifies the YAML file to specify your slice name. So it specifies the slice name and also specifies your server, that's the me9.casa.umass.edu, and that's how the XMPP server, which is me9, knows that this is the slice where it has to run the experiments. So you have an OMF controller sitting. OMF controller is nothing but LabWiki, and that's sitting on me9 again, and that will talk to your resource controllers and run the experiment. And when you your experiment results are saved on the OML server in a Postgres database, but you would not be able to access that Postgres database. So that's why we use IROS, which is a central storage system. I will just talk a little bit about it in just a second. And in that database, you will actually be able to see your experiment results. You can see the table there. It has been implemented in LabWiki, but because of a slight hardware problem, we disabled it for this GEC. But definitely, you should be able to do that in very, very soon. So all you have to worry about is reserving your resources, writing the script, and that's it. Everything else is just done by LabWiki, and you don't have to worry about that. So IRODS is called integrated. It actually stands for Integrated Rule-Oriented Data System. It's a mouthful to say, and that's why I put it up there, because I just can't remember it. But so all your experiment-related data is stored here. And what Professor Zink showed earlier in the plenary is the topology that you could see. Is what LabWiki can also do is pass your manifest RSpec to show you the topology. So that's the new feature that's, which is going to come, which is already there, but it's not there in the LabWiki that you are using now. So you have your scripts, you have a result data, and you have all this information that you want about your experiment, and it's all going to be on IRODS. You just have to go to that link you just have to go to the link called iDrop, and this link will tell you how to get IRODS. For your VM, IRODS is already downloaded. For now, the problem is you can't use IRODS because it's not enabled on your GENI portal. To get your IRODS environment, all you have to do is go into the GENI portal and then click on Profile. And if you actually scroll to the bottom, you can see that there's a Create IRODS or Use IRODS button. You click on that button, and then you will see that your IRODS environment information is right there on that page, along with the username and password. So the password is only shown to you once, so you have to either remember it, which I find very difficult, so I just write it down. So so you can just see it once, and then you use that to configure your IRODS environment. And then that's how you can put data into IRODS if you need to, and get your data if you want to. So iDrop this is what iDrop looks like. So it's a snapshot, so it doesn't look that clear here, but if you go to the actual URL, and when you get your accounts, you can do this. So the experiments will be written, the experiment results will be written into, you can see the experiment templates on the left. Can everybody see that? That's where the templates will be stored, the ones that you can actually see that Shufeng pulled up and ran. That's a template, so that's going to be put there. And then you can see all those different folders where I've run several experiments, and all the data that's related to that experiment is going to be stored in a specific folder. And now I can see everybody's experiment because I have admin access, but you will only be able to see your experiment folders. And when you're done with your experiment, please release the resources because Victor is already too busy. Thank you.